So, what are we trying to accomplish when we talk about malware analysis? Why do you even need that as a CISA Plus certified expert? Well, you want to know if a file is malicious. That is really important. I like to know is if do you have software that's malicious? If the software is malicious, what is it doing? Like, what is that behavior of the software? What is that software trying to do? What is it trying to modify? And who is it contacting? Where is that software actually going? Now, that software, if it is malicious, it's going to attempt to avoid detection. How is it doing that? And what are some of the anti-analysis techniques that it has built in to make sure that security professionals like yourself don't analyze that? That's what malware analysis is all about, and that's an overview of malware analysis. That's really what we're going to get into in the next few sections is, how to accomplish that from a very, very high level overview of what you may need on the exam. Of course, we can go much, much deeper in malware analysis. We can do a whole course just based on malware analysis alone. So these are just touching on some of the fundamentals to get you familiar with it. You're not expected to actually do any reverse engineering, go in a debugger. I'm not expecting you to write malware signatures, but you are expected to know some basic concepts and what they mean and how they work. So let's talk what a malware analysis is. There's a couple of different types of analysis: static analysis and dynamic analysis. Let's start with dynamic analysis, even though it's second on our menu. Dynamic analysis is actually, I think, a little easier in some ways because you're executing the file and seeing what did the file do. That means I'm actually running the file and see what the file did. If I'm going to run malware or ransomware, let's say I'm running ransomware on my file, on my system, and I run it, and all of a sudden all my files are encrypted, well, then I know what it did. It encrypted my files, right? So I think dynamic analysis in some ways is kind of like, click, run, pray, and, hope for the best. But it is a good idea. Like a lot of times, when I do dynamic analysis, I'll be running it on a sandbox system. I will be running it on a system that's not connected to the network because I don't want it going out to the internet and going to the bad guys. But it'll be, or affecting my other systems on my network and spreading. It'll be on an isolated network, isolated system. Hopefully not in a network if you can get away with that. And then just looking at what the system does. Then I'll take snapshots of the system. I'll compare the differences, see what it is. You still need your tools out there. Static analysis is actually observing the file without execution. And so how do you do that? Well, you'll do things like strings analysis, which we'll talk about. You'll look at the registries. You'll look at a debugger in some cases to see what the file is doing. You'll try and do that. You have to be careful in a debugger. A lot of people think a debugger is just static analysis. Debuggers, like when you're stepping through a program, is actually running the code line by line. So it is actually executing the program. So a debugger, depending on how you can use it, can be dynamic analysis, but it's normally considered static analysis. But I have had friends that have actually used their main work systems with a debugger trying to use a malware code, and they didn't realize that they were running the code at the same time, like stepping through the debugger, and all of a sudden their files are encrypted on their main machine. So be very, very careful. And when I use a debugger, by the way, anytime I'm doing malware analysis, I use an isolated machine, not my main machine, even for things like debugging. All right, so that brings me to my next point, my warning. Never analyze malware on non-analysis systems for the reasons I just mentioned. You never want to connect directly to the internet. Sometimes if you do need internet connection, I do recommend using a VPN, or I recommend using like Tor or, something of that nature, just so your ISP doesn't think like, hey, this guy is infected. He's running all this malware. What's going on? Or he's trying to do something a little shady. So let's just go ahead and shut him down. The last thing I'll tell you is always assume you have the opportunity to examine one file, like one time a file. And the reason I say that is because files do change once you examine them. Sometimes they have anti-analysis features. Sometimes when they contact their host, they may look at an IP address. They may even look at a path and see okay, let's shut this down. A lot of authors are definitely very protective of their malware. And so you usually have one opportunity, one shot, to really be everything you can be. I think I was starting to repeat the Eminem song here, but one shot or one opportunity to essentially examine malware sometimes, and you have to assume that. So there are tools, like a lot of people will use virtual machines, but virtual machines do create risks. I understand a lot of people will start using virtual machines for, for malware analysis, and they'll use virtual VMware tools to like copy and paste files, share folders. Definitely makes life easier, but also remember anything that makes life easier could possibly introduce a risk. I've seen people where they are running virtual machines on a Mac and they're running a VM of Windows. They've had a shared folder between Windows and Mac, and all of a sudden all their Mac files get encrypted because the virus would have never affected a Mac directly, but through the VM shared folder, their files got infected. A couple of tools for malware analysis. Remnux is an extremely popular tool. It was actually created by a person named Lenny Zelstar. Lenny is actually a little bit of a superstar, I would say, in the malware field. So I would definitely look at Remnux. It's a very, very well regarded tool. All right, so malware analysis, as we've talked about, there's two main strategies of doing malware analysis: static analysis or dynamic analysis. When we're talking about static analysis, we're talking about identifying the file using hashing techniques, maybe even PE analysis. We'll talk a little bit about all that, what that means. Throughout this course, we've already talked about it a little bit, but we'll talk a little bit about it more. But essentially, I'm really looking at very specific instructions in the file and seeing what they're doing. Dynamic analysis is essentially running the file, unpacking the file, looking at the file. That is dynamic analysis. So all those blue boxes are really going to static analysis. Unpacking the malware is actually a little bit of both. It can be static and dynamic, and the reason for that is when you run malware, it does unpack by itself dynamically, or as a malware researcher, you'll have to unpack it manually. All right, guys, I hope that made sense, and I will see you in the next lesson.